Good morning, students. In this video, we are going to discuss about combining security associations in the IP security. Let us see about combining security association in brief. An individual security association can implement either the authentication header or encapsulation security payload protocol, but not both. Sometimes a particular traffic flow will call for the security services provided by both AH and ESP. Further, a particular traffic flow may require IP security services between hosts and for that same flow, separate services between security gateways such as firewall. In all of these cases, multiple security associations must be employed for the same traffic flow to achieve the desired IP security services. The term security association bundle refers to a sequence of security association through which traffic must be processed to provide a desired set of IP security services. The SA in a bundle may terminate at different endpoints or at the same endpoint. Security associations may be combined into a bundle into two ways: a transport adjacency, which combines AH and ESP, or iterated tunneling, multiple levels of nesting. Let us see about transport adjacency. It refers to applying more than one security protocol to the same IP packet without invoking tunneling. This approach to combining the authentication header and ESP allows for only one level of combination. Further, nesting yields no added benefit since the processing is performed at one IP security instance at the destination. Let us see about iterated tunneling. The iterated tunneling refers to the application of multiple layers of security protocols affected through IP tunneling. This approach allows for multiple levels of nesting since each tunnel can originate or terminate at a different IP sites along the path. The two approaches can be combined, for example, by having a transport SA between host travel part of the way through a tunnel SA between a security gateway. One interesting issue that arises when considering security association bundles is the order in which authentication and encryption may be applied between a given pair of endpoints and the way of doing so. Authentication plus confidentiality. Encryption and authentication can be combined in order to transmit an IP packet that has both confidentiality and authentication between hosts. Encapsulation security payload with authentication options. This approach is the user first applies ESP to the data to be processed or protected and then appends the authentication data field. There are actually two subcases there: a transport mode ESP and tunnel mode ESP. What actually transport mode ESP? Authentication and encryption applies to the IP payload delivered to the host, but the IP header is not protected. Whereas in tunnel mode ESP, authentication applies to the entire IP packet delivered to the outer IP destination address, example a router or a firewall, and authentication is performed at that destination. The entire inner packet is protected by the privacy mechanism for delivering to the inner IP destination. For both cases, authentication applies to the ciphertext rather than the plain text. Let us see in detail about transport adjacency. Another way to apply authentication after encryption is to use two bundled transport SAs, with the inner being an ESP SA and the outer being an AH SA. In this case, ESP is used without its authentication option because the inner SA is a transport SA. Encryption is applied to the IP payload because the inner SA is a transport SA. Encryption is applied to the IP payload. The resulting packet consists of an IP header followed by an ESP header, and possibly IPv6 header extensions are going to be used. AH is then applied to transport mode so that authentication covers the ESP plus the original IP packet and its extensions too, except for mutual fields. The advantage of this approach over simply using a single ESPSA with the ESP authentication option is that authentication covers more fields, including the source and destination IP addresses. The disadvantage is that overhead of two essays versus one essay. It's a drawback of this transport adjacency. Let us see the next transport tunnel bundle. The use of authentication prior to encryption might be preferably for several reasons. First, because the authentication data are protected by encryption, it is possible for anyone to intercept the message and alter the authentication data without detection. Second, it may be desirable to store the authentication information with the message and the destination for later reference. It is more convenient to do this if the authentication information applies to the unencrypted messages. Otherwise, the message could have to be re-encrypted to verify the authentication information. One approach to apply authentication before encryption between two hosts is to use a bundle containing of an inner AH transport essay and an outer ESP tunnel essay. In this case, authentication is applied to the IP payload plus the IP header. The resulting IP packet is then processed in tunneling mode by ESP. The result is that entire authenticated inner packet is encrypted and a new outer IP is added and an extension is also added. Let us see how the combinations of security associations are going to be there. The basics of combinations of security association. The IP Security Association document lists 4 examples of combinations of essays that must be supported by a compliant IP security host, example known as a workstation or a server, or security gateways like a router or firewall. The figure illustrates how the 4 combinations of the essays. The lower part represents the physical connectivity. The upper part represents a logical connectivity. Each essay can be either AH or ESP. For host-to-host essays, the mode may be either transport mode or tunnel mode. Otherwise, it must be a tunnel mode. Let us see about each combinations by one. First, case 1, combinations of security association, case 1. This figure shows a local internet, how it's going to be get connected between one or more essays. All security is provided between end system that implements IP security. For any two end systems to communicate via an security association, they must share the appropriate secret key. Among the possible combinations, AH in transport mode, ESP in transport mode, ESP followed by AH in transport mode, or else A or B or C, any one of the above, inside an AH or ESP in tunnel mode. As we discussed earlier, how these various combinations can be used to support authentication, encryption, authentication before encryption, and authentication after encryption. Let us see the case 2. In this case 2, the security is provided only between gateways, routers or firewalls, etc., and no host implement IP security. This case illustrates simple virtual private network support. The security architecture document specifies that only a single tunnel SA is needed for this case. A single SA tunnel is going to be needed for this case. The tunnel could support AH, ESP or ESP with authentication option. Nested tunnels are not required because the IP security service applied to this entire inner packet. Let us see about the case 3. This builds on case 2 by adding end-to-end security, a single tunnel SA with end-to-end security. The same combination as discussed for case 1 and case 2 are allowed here. The gateway to gateway tunnel provides either authentication, confidentiality, or both for all traffic between end systems. When the gateway to gateway tunnel is ESP, it also provides a limited form of traffic confidentiality. Individual host can implement any additional IP security services required for given application or given users by means of end-to-end SAs. Let us see the last case, the case 4, a combination of security association. This provides supports for a remote host that uses the internet to reach an organization firewall. And then to gain access to some server or workstation behind the firewall. Only tunnel mode is required between the remote host and the firewall. As in case 1, one or two SAs may be used between the remote host and the local host. So in this video, we come across a combination security associations. If you have any queries, please post to me. Thank you for watching this video. We'll see in the next video. Thank you.